I'm going to try and fix this thing. It's an HP8648B. It's got a bit of an issue. Let's see how we go. So as you can see, I've already started pulling it apart. I've got the casings off. There's like an internal plate here which I've taken off already. I've already been diagnosing a little bit. Now I'm going to show you what the fault is, and then we're going to pull out the card which I think the problem is, and we'll have a look at it and see if we can get anywhere. Plug power in. Now this still has a reefer cap in the power supply. The power supply is down here, and the reefer cap is down there. And when I've worked on the HP8647A previously, that capacitor blew up on as I was recording video. So it actually made quite a good video. It went bang and it stunk the place out and that sort of stuff, and I ended up replacing that. But at the time I couldn't actually figure out very easily what the capacitor value was because the cap was blown apart. I did actually manage to diagnose it and figure it out based on its size. So, and I did get the correct capacitor as well when I actually replaced it. I got the right one in the end. So I ended up buying a spare power supply. So I do actually have a spare power supply for the H647A, which I think is probably the same as the news unit anyway. So if if that doesn't completely blow up or something, I've got a spare power supply. But at the moment it's working. No, it hasn't blown. I've had this thing powered up for a little while. It hasn't blown up yet. But with its reefer caps, there's no guarantees it's going to last more than 30 seconds. So, let's try it. So it's doing the self-test. There you go, Synth, out of lock, div, het, main, and X. Fault number 608. Now according to the manual, that fault is caused by either the synthesizer board or the reference board. Now the synthesizer requires a reference board to give it signals, so it knows what the frequencies are. That appears to be working. Now I can actually show you that process of checking those, but there's some things I can't actually test very easily, like 1 GHz signals, things like that, which I can't actually measure. I don't have a scope we can go that high. If anyone wants to give me one, that'd be great. Please do. Keysight, Agilent, the new 5000 series would be quite nice. If you don't mind sending me one Agilent, that'd be quite good. I know you watch my videos. I know you want to give me a multi-$1,000 scope for free. Anyway, so on this side of the board, there's normally a panel over this, which I've already removed. And this is the riser card adapters, so this is where the plugs are for those connectors. And I've already made some notes on this board here about where things are, which I think might be upside down in this orientation. They are. So that's not very helpful to you. Okay, so I've made notes on the board itself directly about what each signal is, and I say it's upside down right now, so sorry about that. But right, so the top board here is a reference card. So you've got 3 cards in there, and you also got one right down the side, which you're going to ignore. So this is the reference board, so it's got a 1 GHz output just here, in theory, although I haven't measured that. And then we've got some data connections and power supplies in the centre. They're all very similar on those two connectors. They've got mostly the same power supply stuff. There are some slight differences on a couple of boards, so it's not all identical on this RS232 connectors. Then we've got 1 MHz and modulation output and 10 MHz over here. So I've marked on these where they connect to. I mean, this is on the block diagram of the unit anyway, but I just did that for simplicity, just so I knew where to check for and what interconnections there are, just for me to make it a bit more easy to diagnose. Now I've already measured these outputs on this reference card, and they are there. I can't verify is the 1 GHz. I did try hooking up to my Fluke counter, but couldn't detect anything, so I'm suspicious about the 1 GHz. My scope can't see it, my Fluke counter couldn't see it, but the Fluke counter can be a bit finicky about things. Sometimes it doesn't actually register things on there, so it's not completely surprising. So I'm thinking that the synthesizer card is not the issue, because the 1 GHz output goes through to the final card here, and that one basically bypasses the synthesizer card, so it shouldn't actually give that error. That's the RF output board. So I'm pretty sure the issue is actually that Signal Generator synth card, which I'm going to take out now. That's the one I believe has got the fault, but I could be wrong, because the RF output card, which is this one, does feed back into the synthesizer. So it could even be that 1 GHz signal missing from the reference, which is causing that problem. But it's leaning towards being the synthesizer, so I'm going to take that board out and we'll have a look at it. We'll strip it down. Let's pull this board out. hopefully without snapping these tabs off. So I think this is the problem, is this board here, this module. So here you can see the interconnects. So it's got like a, was it DB9, is it? DB9 connector? And you've got some header connections as well. So I'll pull it apart. So these screws here, they use a Torx 10, in case you're interested. There's screws on both sides. I'm going to take away the top side first. Based the way that came out, these haven't been out ever. I don't think they're really like, they feel like factory. You're really tight, like locked in, like seized initially. So that's like a good sign that it's never been pulled apart. See? I think no one's been playing with this at all, which is good. Now I do have to take out both sides. I might have to actually. So I do, because the card's got to slide out completely. That's okay. I'm always a bit happy when I get something which no one's played with yet, because at least I know that I'm dealing with the fault directly, not with some kind of side symptom or some other thing which is going on where someone's half fixed it and it masks what the original problem was. There's like a foam pad right here, so maybe that's what's making it stick. So it does have a bit of movement in this. I think it's just that foam pad. Let's see if I can slide something up there to free that off. Yep, pretty sure that's what it is. Just shoving a spudger down there between the foam and the casing, just to break the connection there. Pretty sure that's all it is. Okay, here we go. Must make sure I put it back in the correct way around. Mind you, on the casing here it says component side. Just there, so they've already thought of that. So let's have a look what we're dealing with. I don't see anything obvious yet. So bodge wire over here. Okay, so there's the back of the board. I can't really see anything on there, so there is that bodge wire just over here. There's nothing obviously wrong that I can see just by glancing at it anyway, which is a bit of a disappointing. There's also a metal can here which has got some of the RF gear goodness in it, but I don't want to open that unless I really need to. I'm hoping I've got no reason to go in there. And that's what the other side of the board looks like. So it should be a good close shot for you to see everything. So if you see something that I don't, yell out. So it's got some jumpers on here, a few test points. I don't have a riser card for this, but I think when it's in the casing, most of it's probably going to be accessible anyway, like these test points at least will be accessible. I may not even be able to get any information about what I need to test. I haven't found anything obvious, but I was looking for circuit diagrams mostly in the manual, and there's no circuit diagrams, just a block diagram. So I thought I'd just go around, just do some basic testing on this board itself and see if I can make any sense of maybe it's a bad part, or maybe I was going to find something which is burnt out or whatever, but there's nothing visually that I can see looks bad. There's a whole bunch of tantalum caps, but none of them look like they're discoloured. Usually if they go, you might see some discoloration on them. They'll change colour, especially on the dip tantalums. They're really obvious for that. They're really bad. These ones maybe not so much. I might just short out and may not see anything, but I'm still visually checking. I cannot see a problem. So we've got some voltage regulators here. We've got an LM317T and an LM337. So, you know, checking power supply is always a good thing, but because it has to be inside the chassis to do that, it could be a bit tricky. This board's number is in 08920-60373. The next line is -3532-10. Next line is BE3-0. I was hoping to see some physical damage, so this is going to be harder than I wanted. These cards are available. We can buy, well, there's some of these on eBay, these boards, but they're hundreds and hundreds of dollars. Let's just do some basic checks, just check for shorts and the tantalums, that sort of thing. So I'm hoping it's just a bad tantalum, because that would be quite nice, but I think it's probably more serious than that. And because of the complexity of this board with no information about how to fix it, no circuit diagrams make things somewhat harder. Okay, well, that's all the tantalums checked. They're fine. So let's look at diodes. Next easiest thing to check. Put it on die test and I'll do that, shouldn't I? Bear in mind, being in circuit means you could well get some weird readings like I am on this one. Yeah, the reading's going to be wacky because we're in circuit, so I don't really rely on the diode readings in circuit unless it's a case of just checking for a short circuit. So we've got here AD717, AD717, AC, this is 74 series I think, AC74X AB714, maybe it's not a 74 series, that's 74 series there, 74AC00, there's also a Motorola part there, wherever that is, 18211254, it's a HP part number of course, and we've got another HP part number here, 1820-6472. It's probably a little microcontroller thing. SCX6206TQM. AD7545AKP. SC64020A. MC33284. There's a quad op amp here, TL074. So ZT quad 2A. There's another one there. Another AD717 over there. So it's quite a complex card. So trying to diagnose it part by part could be interesting. Trying to figure out the design. And with that circuit diagram, it's like this is going to be almost impossible. So I'm just hoping to find find a bad part. So let's look at some of these surface mount transistors on here. I'll get you reading from one of those pins on that one. That's a Z3P 7.8 or 7B. I think it's 7.8. So Z3, then a small p, then 7.8. Those two parts are the same parts, so I should be able to do a cross check between them. And see if there's a difference between the actual parts. If they're both the same, then that's probably alright. Yeah, it's been the same. So I think it might just be like a surface mount diode. There's a whole bunch more of them across here. And none of them are using that other leg, which isn't giving a reading. So I think it is just a surface mount diode in a SOT3 package. Reading's a little bit weird in that one. What is it? 1AM8. There's an underscore underneath it. So 1AM in the horizontal plane has got an 8 and the vertical plane with a line underneath. No idea what that is, anyway. When it comes to the serviceman coding, it's not something I'm particularly good on. The trouble with testing a circuit, you're not quite sure what you're going to get anyway, because it may be circuitry around it. It does have a connection. I'm still suspicious. I mean, I don't know if these are local regulation, maybe, I don't know, but what's this one here? This has got 3 connections that give me some interesting readings. That's this one. M1FT. M1F space T. And this one, maybe there's a regulator there. Little service mount regulator, quite possibly. Yeah, I don't know, I'm not getting anything conclusive from this, am I? It's not looking good. That measures, finally, I've got one that measures normally. Yeah. Probed around a little bit more, haven't found anything else yet, but let's check all the ceramic capacitors out, because you never quite know, because they do fail, and they fail short. Yeah. That's a definite short. But then there's a resistor in parallel with it, so let's measure resistance. Five ohms, thereabouts. Doesn't seem quite right. Okay, so there's a possible one here. I mean, my probes are about an ohm or so anyway. So it's like 4 ohms across this cap. So that's a suspicious one. But the only problem is with these caps is I don't know what to replace them with if I do find a bad one. That's right. Good. So I'm suspicious about that one over there. That's an inductor. And that is not an inductor, that's a capacitor. But it's in parallel with a resistor. Definitely is that one. .68 ohms. 68R1. So yeah, that's fine. That's okay. So I've got one resistor, one capacitor which I'm suspicious of up here. Question is, what the hell is it? So I'll show you what I'm looking at. And it is this one right there. It's giving 5 ohms across it. So you've got a resistor this side, it goes through to a via, you've got that one there, runs around to where? Goes to another via, I think. Yeah, another via. So it's got 3 vias. That resistor goes to those two vias, and then the other end of capacitor goes to that via. So let's try and translate that around to the other side of the board. There's a whole bunch more on the back. I should look at the back of the board too, shouldn't I? Measure that stuff. So it's in here somewhere. Just here. Can't quite tell, but yeah. I'll keep that one in mind anyway. So there's a whole bunch of ceramics on this side which I also need to test. So ceramic caps because they've got very close lying plates within the ceramic package, they can short out if physically stressed especially. So I'm not expecting this to be a problem on this particular unit, but you never quite know. Having experience with ceramic caps failing a lot in MacBooks, you know, it's a consideration. Although this era of stuff probably has slightly better quality caps because they're fairly new, and I think they hadn't cheapened the design at that stage. Or maybe it's just to do with the values, maybe this, because the higher values in MacBooks maybe they have to pack more in there so the layers are thinner, so maybe it's more prone to it because of that. So I've got one which I'm suspicious about. Let's just check this one transistor's down here, which has the bodge wire on it. Which isn't making a lot of sense with readings either. BOL with smart tests. Oh, okay, there we go, now I've got a reading. Is that a Schottky? Might be a Schottky diode. I think there must be diode packages. So I only found one suspicious thing so far. Well, I'll just try and trace it out. I don't open this can up unless I need to. Let's check the voltage regulators actually, just see if there's anything obviously bad on these, you never know. Oh, that looks very low. On the LM317. Mind just an adjustment, isn't it? LM317, that's the adjust pin. Maybe it's okay. Just unsure. I mean, these are ICs, they're not really transistors, so you can't measure them in the same way. It's probably just adjustment stuff. They're not a direct short anyway. The only thing I've found so far is that one cap. Could be that. I'm suspicious. Okay, so I'm going to try taking this capacitor out of circuit. I'm going to use soldering iron rather than hot air because some circuit board types of the solder style do not like hot air. You can hot air one will delaminate and destroy the board. So I'm not going to risk using hot air, even though it's what I prefer to use on this. Just because I don't know if it's going to be okay or not. I'm not going to risk it. So I'm going to use my iron here and heat that capacitor up and take off the board with a bit of luck. Stick some flux on it. Add some fresh solder. Try and get it off. I'm hoping I can just use this technique and slide the thing off. There we go, it's starting to move. Come on. Okay. Oh, let's pop back on again. Of course it has. Come on. Off you come. Give me tombstones, I'll be happy with that. That's out of circuit. Now I can retest. Now last time I was getting 5 ohms. See if that's changed. Still getting 5 ohms. So it's not that capacitor. So that probably isn't the problem. Damn it. Right, so after much messing around, I pulled this thing apart, checked it all out, can't find any faults with it. It all seems fine. Now, for some reason I had 1 megahertz in my head as a reference frequency for this board. And that's what I was getting. Maybe that's because that's what I was getting, maybe that's why I had 1 megahertz in my head. Now, looking at the manual again today, after spending a few hours working on this thing, trying to find what's wrong with it and diagnosing it and figuring out the circuitry, because there's no circuit diagram for this unit. There is a similar unit which I've been cross-checking against. It looks like this board's probably working fine. I think the issue now, it comes back to being the reference, which I had already eliminated thinking it's okay. Yeah, I think the reference is actually wrong. It's outputting 1 megahertz when I think it should be 200k. So we're going to put this board back in again and say this one actually appears to be okay after all, and we'll put the reference on the bench and pull that apart and have a quick look at that. But it looks like it might be missing a divide by 5. So here we have an OCXO, 10 MHz OCXO. Got these shielding cans over here. Oh look, it's had some soldering done. Interesting. So here you go, it's got some flux on here. This looks like it's had some work at some point. Maybe, I don't know. Maybe some time ago. Anyway, there's an awful lot of logic on this board from what I was expecting it to be. It's got a reference adjustment here, but it's not used. It's got a jumper here, jumper there. What do they do? It's always curious when you see jumpers. So the model number of this board is a 08920-60-519. Still a fun circuit diagram for this exact board. If I compare this board here to the other board, which is the 8920, very similar. This is the newer revision. This is newer. This is 1997. And then the manual information we've got is 1991 or so, 1992, around that kind of region. So this is a later revision of the board. U3 appears to be the same device and the same designators. Most of it's very similar, exactly the same placement and everything. So I'm going to put a couple of little wire leads on U3, which should be the parts. It's part of the divider section in 2 different spots. So the first point should be measuring 1 megahertz and 200 kilohertz. That's what I should be measuring on those 2 points. If I'm getting something other than that, it tells me which part of the chip is blown. That'll at least confirm to me that it's this chip which is the problem as well. Oh, lost it. So I'm just going to solder on a couple of component leads so they can become test points. When I slot the board back in again, I can hook up to those with my probe. Well, that's the plan anyway, if I can get them on straight. Don't touch them together either, that wouldn't be good. Mind you, it probably wouldn't do anything, you just mess up the divider ratio. Okay, that's one on. I just lost that one too. Go on. Let's get another one. I have a few lying around right now, so I'm not too worried. Replacing capacitors, so I've got a whole bunch of leads. Well, we'll find out soon whether I've got a good plan or not. Or whether I've got it completely wrong. Again. That's better. Okay. Let's drop this back in the chassis and we'll probe it and see what happens. Moment of truth coming up soon. Alright, slide this back into the board. Okay, let's power it up. Let's probe on here. So this will be pin 9 and I'm getting 1 megahertz, and on pin 10 I'm getting 200 kilohertz. What the hell? That's right. What? Okay. Still getting the same error. Okay, now I'm confused. What the hell? Right, so I soldered a wire onto pin 8, which is the output of U3, and we're going to see what that does. Because in theory it should be a 200 kHz output still. Power it up. And we do still get a 200 kHz output. Duty cycle was saying 95%. So we've got 4.8 microseconds and 200 nanoseconds as the timings on those. So that's at 1 microsecond per division. So, but we're getting 200 kHz out, which is odd because that's not what I'm seeing coming out the card. What the hell are we missing? Let's keep looking. So I'm playing around trying to figure out what's going on with this HP8648B. Now there's no output and stuff like that, so I think it's got more than one problem. I think the 1 GHz output from reference isn't working, which is over here, and I think the synthesizer board has also failed, which is what it's giving an error for. But the 1 MHz / 200 kHz, whatever the hell it's supposed to be, output from the reference to the synthesizer is there. The manual is a bit unclear. Some block diagrams show it as being 1 MHz. Another block diagram shows it as being 200 kHz. All the text references it as being 200 kHz. But it's definitely 1 MHz coming out. And one of the things it said is that the reference voltage comes in, well, reference signal comes in to the synthesizer card and to the A3 main board. That is divided by 200 or 500, depending on which modulation frequency you got chosen. In order to get the modulation frequency, now if I plug this in here, modulation on. Can I see that? I'm not sure. Maybe not in this situation. But I was actually getting. I can't show you right now. I'm not set up for it. But the let's go in. I can't actually see the screen, the angle on that and stuff like that. Modulation. That is on there. That's modulation on. Can I see it or not? Looks like not. I don't know. It was there before. I was testing something differently. Anyway, the I was saying. So the modulation was there before when I did check it, when I did testing on that, and I verified that the frequencies were correct. So the modulation output, which is divided by 500 or 200, depending on which one you've got chosen, 1 kHz or 400 Hz, those are correct frequencies. So that means the reference was outputting the correct frequency because the motherboard's dividing it correctly. So that 1 MHz must be right. It has to be. So yeah, I don't know why there's that difference between 1 MHz and 200 kHz in the manual. It doesn't explicitly state why one could be 1 MHz and one isn't. Anyway, so what I'm doing now is I've got my Marconi signal generator set up here. It's generating a 50 MHz signal at 200 millivolts. Yes, I'm using millivolts, not dBm, even though it's RF, because I'm trying to keep things in a logical way, believe it or not. And if I connected this probe, which has got the signal generator on the end of it, at ×1 probe, if I inject that signal in here, you'll see I'll get a voltage. You see I'll get a signal there. Let's just click my ground probe on because I had that popped off. No, don't pop off. I don't want to stay on there. Come on. Okay, so there's the probe on there. That is on the RF input of the output board. Right, so the RF signal is supposed to come from the synthesizer board into the output board, and that signal should be a correct signal. And if I don't know if you can see it up there, probably can't. It's all moved, sunk down a little bit. But up there, it says 50 megahertz. So it will amplify the signal I'm putting in. Kind of. This is the next interesting thing. If I do something like 10 megahertz, it doesn't come through. Or 100 megahertz, it doesn't come through. So that's a bit weird. Now the other thing is, the 1 gigahertz signal which comes through, or supposed to come through from the reference, which is missing, I cannot detect it. Even when I've had my CMU200 hooked up, my spectrum analyzer, I probed around here and there's definitely no signal here. If I stick that on there, I'll get 50 megahertz coming out. Because it mixes those two together to generate an output. So the 50 megahertz will come straight through, depending on what setting I've got on here. Right, so if I think I'm on 10 megahertz or something right now on the front, let's have a look. What are we on? Get 10 megahertz. So if I change that frequency, it won't come straight through, so it's done in blocks. So I think, let's try some 300 megahertz. See if that still does it. No, see now it's not coming through, because that's the next block of the mixing. So some are mixed in different ways, and that particular, up to 249 megahertz is one block, then it's another mixing block and another mixing block and so on. The output board is kind of working. It's doing some mixing, but it's got missing signals, so therefore it's not generating the outputs it should be generating. So yeah, it's not right, because the inputs are missing. So I think that what's happened here is I've got a unit which has got more than one bad board in it. So I'm trying to chase a problem thinking I've got one fault. Well, actually, I think there's more than one fault. I think there is a bad reference and a bad RF synthesizer board. Because there's definitely no RF output from that synthesizer board, so I've purchased another synthesizer board. It's entirely possible that the logic board is programmed for a different reference, because there's the standard reference, which is what's in this one, and there's also a high stability reference, which is like a bit better. It's like 50% better or something like that. Maybe that's been taken out, and this board is actually programmed. It's told what boards are in it. It's done through GPIB and a bit of software. I haven't ventured into that part yet. In theory, I should be able to get this to read through GPIB and read what its configuration is supposed to be. Maybe it's got the wrong configuration. Maybe it's expecting the precision reference instead, which may have a different output configuration, or who knows. Yeah, it's a bit confusing. So that's where I'm at right now. So I thought I'd show you that. So that at least the output board will output a signal. It is passing through. So that's something, but obviously before that point it's broken. 1 gigahertz signal missing from the reference, and the synthesizer board not working. That's what I believe. So I thought I'd show you that modulation thing just to prove it does actually work. So this is, there you go, 1 kilohertz modulation coming out. If I change to 400 hertz, 400 hertz modulation coming out. So the output modulation is correct. Therefore the reference frequency must be correct at that point. So yeah, it's a bit of a mystery, right? It seems to be half working. Go figure. Anyway, moving on. Right, so I started probing on this card over here. Now what I've done is I've put on a little lead, just a little wire, like a bit of resistor lead or something. So there we go, you can see I'm clipped onto that little wired lead, sticking onto that board there. That is tacked onto the 1 gigahertz output. Right, now I think 1 gigahertz, I don't have a scope that can cover 1 gigahertz. Well, no I don't. My scopes don't cover that. There they are there. There's my signal, which I've hacked to 340 megahertz or so, and there's my 100 megahertz Keysight. So yeah, I mean, no, this can read more, but yeah, it's not what I'm doing. So what I've done, this probe I've got hooked up to my Rohde Schwarz up here. So here's my CMU200. So here's my CMU200, and I've got that probe going into that. So I'm using the spectrum analyzer function on here to check for the 1 gigahertz signal, because that's the only thing I can actually use to check for signals. If anyone wants to give me a 1 gigahertz scope, that'd be great. I've got a 1 gigahertz signal showing up on here. If we check the peak, it's showing 1 gigahertz 0.89, so it's off by a bit, which is interesting. Whether it's this which is off or whether it's the HP which is off, I think it's probably the HP. Now that frequency is derived from the 10 MHz reference in the HP, the built-in reference. So it's it could be the internal reference is wrong, it's off frequency, and that's throwing off the 1 GHz by quite a bit, nearly nearly a megahertz. So that's quite a big difference. So we'll see if that's a problem or not, but we're getting the signal here. So at least I know that the 1 GHz VCO is actually running on that board, on that reference board. It is working, but it's not getting back off the board. So now all I have to do is find some other scope points where I can probe into various parts of the circuitry and figure out where it's going missing. So this is where I had the test point hooked up before, it's TP9, and now I've moved it down here to TP10. TP10 is after, oh, focus, you bugger. TP10 is after U14. U13 and U14 are kind of in parallel, hook up to the output of that oscillator. So I want to see if it gets the past U14. If it does, then I'll go get onto U13, and that one comes down through this trace down here and down to these test points. So I'm going to test over here first because it's easy to get to, then I'll test over here and go from there. Just try and trace that right through the circuit. Right, let's turn this thing on and see what happens. Okay, we have a signal. That's still there. Okay, so after U14 it's working. Right, we'll switch over to the other test point. I might have to put a long wire on next, maybe get the probe down, but we'll figure that out. I now have a wire attached to U13, well TP11 I think it was, something like that. The interesting thing is, it's quite, it's very inappropriate, a long wire. It's not great for 1 GHz. Low frequencies you get away with it, but this is 1 GHz. It's really sort of pushing it. Move the wire around a little bit. It's changing slightly, but if we wiggle the card, you see that changing a lot. It's very erratic. So I'm a bit concerned that maybe this U13 is the problem. I mean, it's close to the output of the card, but I was getting absolutely nothing on the output of the card, on that pin 3 I think it was. I was getting nothing on the bottom when I did those testings, but now I'm actually, there's something there and it's close to the output. So something going on around there. Whether that wobbling around is normal or not, I'm not sure. It seems like a quite extreme deviation just by moving the card around a little bit. Move the wire, moves around a little bit. If I move the wire around the back to where the actual oscillator is, I think it's inducing some oscillation from that oscillator there. But yeah, I think there's something going on with this card. In fact, I'm wobbling and it's jumping around that much. Can't be normal. I'm going to look at that a bit more closely. Now this is a little bit interesting. This is probe on the 1 GHz, and I'll turn the power on in a second. It's 1 GHz line right here. This is on the bottom of the card on connection pin number 3 on J14. Turn the power on. You watch what happens. So, turned up, disappears, comes away, look, jumping around. What's going on there? Definitely something going a bit funny there. Whether it's the amplifier, whether it goes, because it goes through a couple of diodes as well. It's almost like it's being turned on and off. It makes me wonder. Well, I'm going to show you this. I've discovered something. I've resoldered all the joints on that 1 GHz line because there's that erratic movement there, and it seems okay now. So I've cleaned it all up as well. This is the 1 GHz line on the pin 3 on the jack on the bottom there, and you'll see it pop up over here with the reference markers. And I'll turn the RF output on. If I turn on the RF output, it turns on. If I turn it off, it turns off. It's a switched control line. I wish that was in the manual. Anyway, so yes, that is working. That is definitely working. So that's great. So at least now I know the reference is okay, because the output is coming from the reference, which narrows it down to being the synthesizer board. And if I connect up to the output line from the synthesizer board, there should be an RF output right here. Now I've got this span going from like was it 110 megahertz up to over a gigahertz, and I've got the frequency output set at 100 megahertz, and there's nothing there. If I turn the output on or off, it makes no difference. So there's nothing coming out of the synthesizer. We narrowed it down. It's a synthesizer board. Oh, yeah. Yes, that's what we need to do. Okay, so I'll show you where I was probing. Let's adjust the camera. Sorry about the wobbling, it's on a tall tripod and it's on carpet. Okay, so this is the rack, I suppose, you call it rack, I don't know. The slots anyway, so this is that's the reference board in this line here. Point it, there we go, that's the reference board. So J10, J11 and J7 are the reference. The synthesizer is J12, J8 and J13, and the output board is J14, J9 and J15. Okay, so that's the board layouts in that direction, obviously, as you probably saw from the top. Now whilst probing on here, there's a little, you might be able to see the pen mark I've got on the board there. Going down to pin 3 of this board here, that's the 1 GHz output, which is, as I've found out now, switches with the output. That could have saved me some time if I realised that. Anyway, maybe there was a problem, maybe there wasn't. It did seem to be that there was some intermittent signal line there. I don't know, maybe there was a problem there. Maybe I've resolved it by resoldering and stuff. Also resoldered all the connections on that reference board as well. Resoldered all the joints on the pins and everything on the reference card, just to be sure. So that's that pin 3 right there is the 1 GHz, and then over here you might be able to see another pin mark goes from there, pin 17 over to pin 3 of this card. That is supposed to be the output, so that's supposed to be an actual frequency coming out of there between 500 and 1 GHz, and I'm getting nothing. So yep, nothing there. So synthesizer board, I'm confident that's what's wrong. Yay, progress. Well, now I know it's not the reference card, I'm putting this back together again. I've had the thing out of the chassis obviously for the whole time. I've been trying to troubleshoot, so I can attach wires and probe it and stuff like that. So I can reassemble this. I've already put these screws on the other side. So at least I can put this card away knowing that this one is working. And thankfully I didn't buy another replacement. I've only bought a synthesizer card, so I haven't wasted any money. Okay, is that card done? I'm comfortable this one's good. I should show the model number, shouldn't I? There you go, 61045. Which is a standard reference, it's not the high precision one. So, but it's fine, it's good enough for what I do. Maybe I'll upgrade to high precision reference later on, but I'm not really too worried about it right now. So now I can put this back into the unit and take the next one apart. One which I now know is wrong. Okay, so let's drop this card back in again. Or this board back in, what you want to call it, I don't know. Ironically, I'm going back to the board I started out with, which is the synthesizer board. That's what I was thinking the problem was. Okay, let's push back in nice. And put the synthesizer back out and pull this one apart. And revisit it. Now I've got an idea of what's actually going on there. At least I know there's no RF output, so I can track it back from that. Now, I've had this part once before already, when I was first started out trying to diagnose this thing, because I believed it was probably this that was wrong, but wasn't quite sure. Actually, I'll come back in a second. Needed a coffee in my iFix Stuff mug. You can buy these from my Teespring store. Links are down in the description down there if you want to go and have a look at that. I've got various things. Cups, shirts, hoodies, jumpers, bits and pieces like that. Anyway, moving on. If you want to help support the channel, make sure you do things like go to Banggood using the links down below, and make sure you bookmark that link so that you can use that in future to buy things in Banggood, because that way it's allocated to my affiliate account, and I get funds from that. I'll get extra funding for the channel, which is always great. And same thing for at the Amazon store. I've got an Amazon store you can go and buy things from as well. Again, you don't have to buy the things that are in my store, but if you use the links to get there, then I get credit on my affiliate account there too. So back to the synthesizer board. I think I need some more coffee. So something I'm going to do this time, which I didn't do last time, is open up this tin. I want to see what's inside here. Now, I've already checked all the componentry that I could previously, just individual checking, just basic stuff, you know, transistor diodes, shorter capacitors, that kind of thing. Didn't find anything at all. So let's look inside this can, see what's going on inside here. Probably not much, it's probably just some bit of OF goodness. And me opening the can up is going to ruin your calibration. Or it may not matter. We'll find out. But no calibration doesn't really matter if you've got no working board anyway. Right, let's have a peek under the hood. Let's get closer with the camera. Come on, focus your bugger. Here we go, you're just about focused. This is gradually coming up. It's got like a seal around the edge.